GMD is calculation of geometrical mean distance. So geometrical mean distance. So we can calculate at a time geometrical mean distance and also geometrical mean radius. Geometrical mean radius of a short single circuit line or double circuit vertical configured line or double circuit horizontal configured line. So this is how we can for execute this. The simple for you have to use this program gmd dot small m. It should be present in this the current folder. If this present in current folder, if you just type in command window, if you type the command window, so you can, so just if you type the command window gmd, so it will come. So like this, so you want to perform the calculation of the GMD short circuit, single circuit line or double circuit vertical configured line or double circuit horizontal configuration. You can calculate for single circuit line. You can click 1, you can enter 1. So if you enter 2, you can calculate the double circuit vertical configured line. If you enter 3, you can calculate the double circuit horizontal configuration line. So for example, you can see this. You can see this. For this is a single circuit line. For how it is single circuit line means, for conductor, if it is if for a transmission line it consists only one circuit, so that is called single circuit line. For double circuit line means, for it consists two circuits. So for transmit the electric power, it use the two circuits, that is called double circuit line. If it consists only one circuit, it is called for single circuit line. Again, so in single circuit line, if each phase consists single conductor or bundle conductor, that is also important. Here it is only single conductor is there. So in this phase conductor, this is A phase, for example, B you can see, consider this is C. So it consists only one conductor, no bundle conductor here. This is a single conductor. So that is, you can see that the distance between A to B is 1.6 and A to C is 1.6 meter and B to C is 3.2 meters. So this is the single circuit line, no bundling effect, this is. For this is, you can consider, who will calculate the GMD and GMR. This is the GMR. So this is the GMD. So we can't calculate the inductance with this experiment. Only we can calculate with GMD and GMR. So we can see, coming to the first, we can select 1, enter 1. For here you can see that there are two configuration. Here you can observe that for one it is horizontal spacing, another one is triangular shaping. So here we can enter the values in meter or feet. So that is meter or you can enter the values in meter or feet. So that is, for you want to enter for meter, so you can select M, or if you want to select feet, you can select FT. So that is, you can first we want to select the values, enter in M, so you can select N. So now we have to value for D12. So that is, first here the configuration is look like, so A to B is considered as a D12. So that is 1.42. we can see in this diagram. Once again we revise the, for this is DAB is 1.6, DBC is 3.2. for DAB is 1.6. for DAB, here you can use DAB is D12, that is 1.6 meters. For that is next, DBC is 3.2. If you have any doubt, you can, we will see once again. For DAC is once again it is 1.6. So we'll check once again. So you have any doubt? This is, you can see for A to B is 1.6 and B to C is 3.2, C to A is 1.6. Here you can see A to B is 1.6, A to C is 1.6, so B to C is 3.2. So you can, for this we entered for the values. So the next we can press enter. For the same, for here the conductor size. So this is the distance between the conductors, three-phase conductors. For that we entered. For now we have to enter the for the radius, size of the conductor, radius or diameter. For that is for conductor size. For conductor size, we will there is two options only, whether we have to enter the value in centimeter or inches. For we will enter in centimeters. So click centimeter. For that is. For not only the radius, the bundling effect also we have to enter in centimeters. For the conductor diameter in centimeter. Here you can see what the diameter of the conductor is. Here you can observe that the conductor diameter is 0.8 centimeter. You can see that conductor diameter is 0.8 centimeter. No need to write once again cm, centimeter, because we already expressed. So we will enter the diameters, conductor size in centimeters. So this is the geometric mean radius in centimeter. So this is, so we have to geometric mean radius in centimeter. So here the very important, you have to know that conductor diameter for is in centimeter. Diameter is in centimeter. So the geometric radius in is also in centimeter. So what is the difference between the? So generally we know that for geometric radius, geometric mean radius, we will consider for example in single conductor we will take r dash r 0.7788 r, that is we can consider 0.7788 r. So here you can observe that conductor radius is 4.4 because the diameter is 0.8, the radius is 0.4. For the radius is 0.4 for, but we have to multiply with 0.77 for 0.77 into 88, for that is 0.31152. So we can check here, for that is radius is, this is 0.311552 for this. So this is 0.31152. So this is in centimeters, for that is. But here the same problem, here it is expressed in meters, that is. So that's why you can observe that. For here 0.7788 is multiplied because for we consider the internal flux linkages. To consider in calculation of inductance, we will consider the internal flux linkages. So we use R dash instead of R. In this is for inductance. For capacitance we use only R. So we not consider the internal charge present on internal to the conductor. We consider the charge present on the surface of the conductor. So that's why for capacitance calculation we considered R. For inductance calculations we consider the R dash. So we consider the for R dash. So this is the diameter divided with 2. So converted into radius multiplied with 0.7788 to convert into for R dash from R. So that is. So this, so we can see that we can enter this. For number of bundle conductor. For enter one for single conductor, we already considered in the problem. So it is a single conductor for phase. For no bundling effect present in for a given problem, so consider 1. For this is GMD is equal to 2.0158. You can observe that GMD equal to 2.01587. For check for clarification, you can see for GMD for is equal to 2.015 here in this problem. For in our calculations, in according to the MATLAB, for GMD for from textbook answer is 2.015. For here from the MATLAB is also same 2.015. Here we consider the after the point we consider 4 digits 2.015. I mean textbook in our problem solution, theoretical solution, that is 2.015. Here the very important you can understand this. For here the GMRL and GMRC. What is the difference between GMRL and GMRC? For GMRL, just now I told that for a inductance calculation, we consider the GMR as R dash, that is 0.7788. For capacitance calculation, we considered only R, that is the half of the diameter. That is diameter is 8 centimeter, the radius is 4 centimeter. 4 centimeters in meter is equal to 0.00400 meter. So there is no multiplication of 0.7788 for calculation of GMR for a capacitance. For inductance, we multiply with R to consider the internal flux linkage effect. That's why we use R dash, that is 0.7788. For this is for the similarly the remaining for double circuit line or for double circuit line with bundling effect, that we'll see the next problem. For this is for this is the different type of problem. This is not GMD, this is GMR problem. Here you can see that for it is a single, it is again a for single circuit. This is the for single phase line, so it is not the three phase, it is not the for double circuit line, it is not a double circuit line. So here you can get the double circuit line problems. For this is the double circuit line, you can observe that for this is one circuit, for this is another circuit, this is another circuit. For here double circuit line, for two circuits we use to transmit the two three-phase circuits, we use to transmit the for electric power from one station to the another station, so that is called double circuit line. For here the diameter is given for 2.532 centimeters and the distance is given. For the very important, for we have to calculate the distance from A to B and B to C, and for this all, for now we will substitute the values and we will observe the results. Here the values, these are the DA, B, D, C dash, and we will calculate the, will prove whether the values are for this are. We'll see once again this problem will solve using the MATLAB. So once again we type the GMD. For it is a double circuit line. For it is vertical configured or for horizontal configured. For that is very important. For vertical configured circuit we have to enter 2. For horizontal configured circuit we have to enter 3. Here you can see the problem how the conductors are configured. Conductors are arranged in vertical. So you can select for vertical. For that we can type 2. For that is. For here you can see that similarly you can see that same exactly what look like. For that is circuit config, circuit arrangement is shown in the window. For A, B, C, A dash, for B dash, for like that. So you can observe that. For here A, for the distance between A to C, A to C dash, for the right side or the dash. So that is right side is dash. For here you can left side is A, B, C, right side is A dash, B dash, C dash. So that is. For this is two arrangements for C dash, B dash, A dash. Here you can in a for two arrangements you can see in the diagram for C dash, B dash, A dash in right hand side. So we can select first one, enter 1 or 2. There are two choices. You may consider for A dash, B dash, C dash on right hand side, or C dash, B dash, A dash on right hand side. For that is we can select for we have to select first for according to our problem. For first enter. For we'll see once again we'll enter the values in meters only. So select the small m. So that is next. So we have to enter the horizontal values A to C dash, B to B dash, C to C dash. For that values you can see in the problem. For 7.5, 9 and 7.5. This is again 7.5. So it is 7.5, 9, 7.5. These very simple problems for this. For 7.5, for space 9, we have to give space. 7.5 space 9 space 7.5. This. How to enter For row vector, here you can see the vertical h12 h23. How this you can see, h12 is 4 and h23 is again 4. This is he mentioned. So we have to consider h23 is also 4 only. So that is both are 4. The vertical distance is 4. So we have to consider. So that is 4 space 4. So this is next. We have to conductor size and bundling effect for is once again we will enter in centimeter. For that is you can observe that. So here the conductor diameter in centimeter, here clearly you can see the problem. The conductor diameter, the diameter of the conductor is 2.532 centimeter. So here once again, once you can look that for face only one conductor present. So it is a no bundling effect. For no bundling effect. So the conductor diameter is 2.532 centimeter. 2.532 centimeters. For geometrical mean radius, so this is we have to divide with 2 and multiply with once again. For we have to divide with for 2.532 is divided with 2 and we have to multiply with 0.7788. That is for 0.9. So because diameter is for 2.532, radius is equal to half of that. But for calculate the for inductance for GMR for geometrical mean radius for inductance, we have to multiply with 0.7788, 0.98599859 for this is for number of bundles is 1. So it is for here you can observe the GMD is equal to 6.611. For 6.4611 you can observe that the problem the GMD is equal 6.61 only for here in this problem, but in our theoretical calculation we obtained 6.61. For in MATLAB practical value is 6.6117. For we in theoretical we have only two digits after the point. So in practically here it is 4 digits we obtained. So this is coming to the for geometrical mean radius for inductance and capacitance. You can see that for that here geometrical mean radius. So here it is you can observe that geometrical mean radius is 0.318. For 0.318. For the practically is 0.318. So using MATLAB is 0.318. For geometrical mean radius for inductance is 0.318. For theoretically also it is 0.318. For this is for inductance calculation. Capacitance for we not considered this value. For we will not multiply this value. We use only for this 1.266. So we can get for this is the value obtained here. So that is 0.36053. So that is you want we can see in the problem next coming chapter. So we'll see that is for this is similar. This is also vertical configured circuit. So this is the horizontal. For this is here it is a for here you can see that this is the problem for determine the inductance for kilometer for phase of a single circuit. It is once again, but is here it is a bundle conductor. So this is for phase 2 conductors are there. So for this this is again is a single circuit. For that is we will check once again. For here it is 0.3603 0653. We will check in for capacitance. So here you can see in same problem. So we have this capacitance of a double circuit line. For this is same problem. So we consider that is same. The GMD is obtained. Same whatever we used as previous problem. So this is 0.3582 what here obtained. the same problem or you will check 0.3582. So check the problem for this is the same, that is the determine the capacitance of a charging current for when the transmission line example 2.5 diameter is 2.5. This is for here it is small change example 2.5 r dash is r is used. The same 6.61 is obtained mutual capacitance, but is here it is obtained 3.3582, but we obtained for practically for 0.36, that is 3536, that is. So we can next we'll see the next problem. So we'll discuss just now. Vertical configure, sorry ma, horizontal configured circuit with bundle. Up to now we not considered the